Hi, welcome to another PlayBASIC live video. This one here is episode 3, I think it is, in creating a library. So far we've kind of built a really bare bones phrase that can skim through an XML formatted document and pull out, the basic structure of it. Just run it and have a look. So I don't know why I was doing that on this computer again. Okay, so here's the screen output over here. We're actually decoding a project file of itself actually, as those files are XML. This is the actual XML document over here, and we are getting all of the relevant information, but at this point we're not doing anything with it. We're just kind of running through it, breaking it apart and displaying it to the screen. So I think we might sort of well, at least clean up the output a bit and give us some indication of what the parental hierarchy of each piece of data is. Because some of this information here is parent and child sort of structure. If you look at the includes part here, which you probably can't see very well in the video, they've got include block. It owns a couple of tags there itself. It's got include 0 and include 1, so they're children of the includes, and includes is in itself a child of the PB project. If we scan down, there's no files being passed. We've just got an empty tag there, and these other sort of tags, they have attributes, but they actually don't have any data nested inside them. Alright, how are we going to do this? So I'm looking at the version 3 of the project, I guess. Nothing's really changed since last time. I've just updated the date and those kind of things in the file. We'll go down to our loader. This is our XML load function, and we're looking at the phrase string function, which does all of the decoding. Now in here we're going to need it to. I'll just grab a cut and paste of this example material over here so we can sort of see it on screen. Even though the file we're phrasing is not like this, but it's the same principle. If I call them something like parent, it's kind of easier to see that we might have, or if this is our game, for example, an XML file for our game, we might have something more along the lines of we have an aliens tag, and this inside the aliens tag is a list of the sprites that are aliens, and then inside each sprite it itself has the properties about what the sprite looks like and where its position is going to be on screen, all that kind of stuff. Its color and xpos equals 100 or something like that. This is our conceptual XML file. So I think what we'll do today is we'll get to output the child data and the attributes in kind of, so it looks like a sort of type structure. So it'll spit out something like, we'll have aliens, and then we'll have sprite, color. Hopefully we can get to do this anyway. I'm not quite sure if it's going to work or not. We might spit out our data like this. So just so you can conceptualize what's going on and where the data needs to slot into each other. And then we can kind of work out what data structures we want to use. didn't put a y variable. Say y pos equals 200 or something. So we also have a field there called sprite name, and bill would be in there. How are we going to do that? Well, I think we'll have, if you look at it closely, the current parent, when we start scanning down a file, if we're scanning from this position here downwards, there would be no parent with there. So when we find this first one, we have to add it to like a parent list or stack, you might want to call it. So once it's on the stack, if we find another tag after that, we're then checking, is this a child of a parent, or is it the end of that current section? That kind of thing. Yeah, I think we'll call it a stack actually. So for the moment, we'll just have an array. We'll just call it parent stack. We might set this to be quite large. So in theory, we have a maximum of indentations of 1024. We're not going to need that. We also need to know how many things are in the parent stack. So let's have parent stack count. And this is the number of things that are on the stack at the moment. We probably should just have another variable there. Parent stack size, and then later on we can just reference the size variable rather than asking the array how big it is all the time. It's just easier to code a bit like that. So far we've done nothing. Let's put a label. Holds the current parent. So what should happen is, as we go, what needs to happen I should say, is as we find a new section, a new tag in our document, so we found an open bracket, this part of the code, we've made sure it's a legal part, we've scanned ahead and found that it's our section name. At the bottom here we're adding the section name somewhere, aren't we? There it is. Right, so for the time being we're just dropping this stuff to the screen. We might just get rid of that print statement. What if we just do this? And parent stack count equals section name, and then we want to add one to here. So we're going to add our parent here, but we shouldn't actually do that every time because not every one of these statements will be a parent. There you go. Some of these are section names, some of these are not. That section name flag there represents when it finds a closing on the end of a bracket. So at the end of a tag, I should say. Okie dokie. Exit find characters loop. Right, so when we find the closing. Oh. Well, we'll see how we go anyway. I'll just check that. When we're adding a new section name, if it comes back as 0, then this thing actually must be added to a list of parents. Sorry for the confusion. Okay, so if once we've scanned through and we've found our tag, we want to at the moment we're just displaying the stuff to the screen. So what we could do here is we're going, is the thing a parent? Is it in other words, is it a tag that looks like this? Is it something like that? Or it might have attributes in it, but still maybe expecting close, we'll say tag name 1, tag name 2, property 1, some value. Both of those there need to be added as parents, because at some point later on in the document we're going to be expecting a closing tag of this and a closing tag for this. We'll have a bit of a we'll have like a full parent name. I wouldn't normally do it like this, but you could do something like okay. Up here we'll compute a full parent name. We probably should do this before we do that. And we'll equal nothing initially. For parent loop equals 0 to stack count minus 1. Hopefully you can sort of click onto what I'm trying to do here. As I just want to represent this on screen so it makes more sense. When we put this data into a data structure, you can follow what's going on. Okay. So once we got to here, we found a new tag. If that tag is a tag like this, or like this one here, we want to add it to our parents list. But before we do that, we want to make a list of the parents that are available. We'll put like a dot after it, so it represents like a type, for example, the period separator. And down the bottom here, we'll print this in front of that. We'll see how we go. Give it a quick save and run it. Oh, it's going to be annoying again. Do this. Let's have a look. Got PB project coming down. We've got PB includes. Okay, that's cool. PB project. It's found the first one. It doesn't need to be working for includes. Let's stop that for a second. Even though it's already stopped. Look at phrase string, and we can look at the whole array it's inside here. Yeah, there you go. So every time it's found a parent, it hasn't actually, we haven't quite done what we were hoping to do with that piece of code. That's okay. That's what we're trying to work out what we should do with this. So we might get rid of the properties at this point as well. Okay. If we do find the slash and next to the open tag here, then we don't need to add this as a parent. At least that's what I'm thinking at the moment anyway. And at the moment we've got no way of detecting when it's the close of that parent either. Okay, full parent name, this plus this, parent stack. I think we've made a bit of a logical error there. When I said parent count, when there's one thing on the stack, it's going to be 1, but the data is going to be stored at 0, so that's okay. Parent loop. No, just run it again. Just see if we can sort of eyeball what's going on. Okay, that's better. So we do have our initial parent, and PB includes there was another parent, but that was never, there's nothing else inside those. But why are we not getting includes in there? That's an interesting one, isn't it? We skim through till we find the stop character. Oh, we might actually be missing a part of that logic. What happens if that's just a plain tag? So here, if it finds the divide character, and then it's expecting the slash after it. So this is our problem. I do think we are missing support for just this. Check for end of tag. If we do find that, and just make sure that's freshly set, and I want to exit out of here appropriately. Okay, so we're checking for the end of the tag. We do find the closing bracket, so the tag I'm expecting to find is looks like this. So we're searching through, we found our open tag here, we're skimming through the name, and then we find this, and that's the end of the tag. If that's the case, then we have to add it as a parent. We have to make sure our outer loop is positioned so it's going to skip over these characters in the future. Which I think was just missing logic from the other example. Yeah, I'm sorry, but this has all got a bit of a whirlwind. I'm genuinely just writing this off the top of my head. If you've got a better idea, leave it in the comments below. We're just opening it for some very brutal conversations. Anyway, let's give it a go again, see what we get. Why is it doing that? Okay, so we should actually have include 0 should be behind pbproject.includes such and such there, but it's not, is it? So includes is a parent, include 0 is that. What are we missing there? Okay, so we find includes. We're not updating this all the time either, so it's critical that it's found in order. And this would give the I think we do actually need to do that after we add it. Yeah. We get includes in the other ones below because there's no logic to close. See how this closing includes tag was found here? There's no logic to find this or to close out that section. Yeah, I've got a bit of a problem here too. It's going PB project includes because it's just kind of displaying that structure. What we probably should have is a bit of code there that actually works out if we're not adding this to the structure. Yeah. Well, what I mean is that we'll probably, and that would sort of make it logically simpler at the moment. I'd rather it worked and be slow than didn't work and was fancy. So I think what we'll do is we'll go we might compute that all the time and then simply add this on to the end if we need to. It's not an elegant solution, not by any stretch of the imagination, but you know, we should kind of get an answer. Trim right. I'll just pull that dot character off the end of that. Okay, so our logic is if it's a parent, we add it to our stack, we bump our counter in the stack. We're not bothering to check if we're going to have any overflows because it is possible, but for the time being we won't bother, and we won't, just don't print that. We'll print full parent name should be the full parent name. Should be. Well, we won't find out. Is it? Oh, it's not. We've broken something. You gotta love that. Oh, of course not. Trim right, we need a string there. It compiled because the last value was optional. It defaults to. What do we got? Right, PB includes. We are getting the parent, but we've got no tag. If section name here was added to that, yeah, sorry, we've got a situation where it's going to add the tag twice, and I just don't want to do it twice. I do like the idea of having a logic in there twice. So we run it again, we'll see these things here. Where are we? Includes. So this is the parent part of the string. This is the current tag. I guess you could just do oh no. Yeah, sorry, just have a little bit of logic double up here. Again, I'm more interested to see if this thing's going to work. We only strip this off right when this is a section tag 1. Then we want to add section name to it. If it's not, we want to strip that off. I can put that backwards, haven't I? Yeah, well done. So add section name to the end of that. We're trimming that off. We don't need to trim it here. We only need to trim that off when it's sorry if you're getting lost. So if we fall through here, we're going, if this tag we currently found is looks like it's a section name, we'll add it to our stack. We just run through our stack and make a string that represents the parental hierarchy of whatever this thing is. And down here we're just sticking the section name on only if it didn't add it here. If it did, it just trims off the string. It's at the end. It's pretty ugly, but you know, we're just trying to get this display on screen. Oh, finally. Sorry about that. It took a bit of stumbling around. Okay, so we've got PB project. Look over here. This does show the hierarchy of the file. We've got one fault though, so we haven't actually bothered to, when we find the end of a section, we haven't bothered to pop the last value off the stack. That's what we'll do now. So when you find it finds this end include statement here, it'll go, okay, pop the last one off the stack. Probably should check if it matches, I guess. And that should give us this kind of structure. This thing that we're sort of hoping for anyway. I'll get rid of that print statement there. We don't really need that. Just want to keep the hierarchy on screen. So this alternate path here is detecting the end of a section. So here it's found this is the close of the section. And I'll be a little bit more polite when I'm checking to see if it's a closing statement. So when we find the close of a tag, we want to check. We'll make sure that there's something on the stack, on our parental stack. If this thing is larger than 0, then that's okay. So I'll get the we get the top parent from stack. The top parent is going to equal this. And I'm going to subtract 1 from that. So we're subtracting first and then grabbing the parent. Now when we do a comparison, we'll just print top parent out there as well, or a little message, you know, this is the end of the parent, something like that, just so I can see it on screen. Fluff that up. Let's give it a run, see how we go. What do we get? Okay, so it's found our includes is this, and here. It didn't actually check though, did it? We found a check they're the same. So I'll force them to be lower. We'll compare lower of this. I've got a feeling that's actually got the other character in it, hasn't it? I'll print this out correctly. So if we get to here, we've found closing tag. And if that didn't work, we actually need to have an error in there because we're expecting, if it wasn't that, what's happened is that at some point an open and close tag have been muddled up inside each other. Error, unexpected closing tag. That'll do us for the time being. This is the section name. Unexpected closing tag of I actually find if I make my errors in my little libraries a bit more verbose, it helps dramatically when I'm having to work out what the hell's what's going wrong with my program. Here it should actually fail, to do. Okay, if this happens, then we can't understand this document, Okie doke, let's give it a go again. Let's see how we go. Yeah, we're getting an error. It's telling it. See, error expecting closing tag of this, because we've left this character here on that. Let's just do a little bit of if we adjust where it grabs, we should actually just get the section name without the backslash on it. Error unexpected closing tag of includes, expecting includes. Oh, it seems a bit bizarre. Typo. See that? Section and then name is here. It won't pick those up for you unless you run in explicit mode. How are we going? So I did find the closing tag, and we do have our. We find includes. We've stepped out here, and our is dropping on the end there, and then we're going down. That seems to be correct. Okay. So when we do our properties, yeah. So we're getting our, when we look at our properties, if this has got some properties with it, what we might want to do is we pass this full parent name across to here, into code properties. We can kind of get to list out these properties for us. Just call it that. Oh no, don't do that. Parent name, we'll call it. We'll just drop it into where we display it. How's that sound? Parent name. So we've got key and data. Let's print this as print parent name plus key. And this is the data. And that won't work, it won't compile, it will expect this parameter to be passed in. So we'll try this. Which is what it wants. Let's try and run it. What are we getting? That looks alright actually, doesn't it? We've got our hierarchy kind of shown here, our data in here. Yeah. All right. Just try and clean that up a little bit more for us. Hopefully you're kind of getting an idea of how the thing's going to store this data in memory. Oh yeah. Sorry, I'll get rid of that closing tag stuff. So I'll only display a closing tag if there's something wrong with it. If we found it correctly, then that's all good. And if there's an error, then we want it to stop and do something with that. Handle closing section name. I've been calling it tag, slash tag. Let's give it a go. And that's our document represented kind of as a hierarchical structure. So our property variables here are coming out as over here they're represented as pbproject.includes.include0.name equals the string, the visible cursor name. I guess what we could do is we could have, I guess, a two-dimensional array or just a one-dimensional array, and you could request, if you know the properties that you're looking for, you just go in your string, you'd have pb project includes. Yeah, give it the full name of the thing you're looking for. PB project includes 0. If that existed, then there are fields in there. If it doesn't exist, they're not. Hope that makes a bit of sense. The way you might do that is where we're displaying this information down here in this decoding routine here, you can pretty much just drop them onto the end of a global array, which would mean that the whole library is a single instance. So you can only ever load one document into memory at one time. Now, of course you could make it so you didn't have to do that, but in terms of in terms of making the document, making the library quickly and it might be a way to go. We might just try that. Let's say we'll just have a string array. We'll have this. We might give it a weird name, so it's kind of like a private XML document. I think we might give the structure initial size of 0, and then we'll just dimension it when we need to use it. When we load a new document, we probably should have here a private function that resets our private document. So what if we just have our document is just pairs, or we have, you can have document keys and document values. You can have just two arrays. Document keys and data. Dim, private XML dot count size, I guess. Document size, and that will be 0 initially. somewhere else down here we'll have a little function. You know, make it a private function, standard XML reset document or something. Oops. Just grab this and throw it down the bottom here somewhere. We don't really want to see it after it's made, really. When we're loading our document, we want to make sure we call this to make sure that we're initializing our document. So this will, you know, reset internal arrays or init. What are we going to do? So get the phrase string here, and really all we need to do is add the properties to it. I think, at least, anyway. So we could have something, another little, just kind of to save space, decode properties, or do something else equally as ugly. Or I don't like these solutions generally. I find them to be Z XML add key. For the time being, I'll just, when we add a key, we've got to check get array elements. It's going to make sure. Actually, look, a better way of doing that is we don't want that there. Size will indicate, or count actually. That's the number of things that are currently in it. This will be max size. So when we initialize the arrays, we'll set them to, like, you know, 4096 lines or something like that. These are globals, so that's why we're trying to make sure the names won't clash anywhere else. And here I can just go, you know, is size actually going to be a problem? Is our count going to overflow? Count is going to be the number of items. If count is less than this, the max size. If it's not going to be, if count is ever going to overflow, like 6, we'll just have a bit of padding there. So when we're adding a key, we'll get the max size here. We'll add, I don't know, 1024 lines to it, and then we'll do a redim of these. So I'm going to keep the keys and data in parallel structures. Redim max size. And that will preserve the data that's in there, but expand those arrays out. So they should be empty initially. And for here, we just want to write to the current count equals key. I'll just do both in both. I want to get through get through to that sort of doing something. Okay, now in our properties list we can add this across, and we should get phrase document decode properties, right? So while we're printing the stuff out, we can just add it here. Add key and data. The variables just happen to match up, which is cool. We'll run it and see if nothing's gone wrong when we've done this. And something did go wrong. I've left that function at the top of the code. Don't need that, but we do need to change these. There's a global. And that's wrong variable name, is that this was count, and that was max size. Let's run again. I compiled, and it didn't die, so head across here, have a look at the data structure. Okay, so it hasn't quite worked. Our addition function here is not working because we are never actually bumping the counter. What we probably should do is we should store this key in a standard searchable fashion. So whether we push it to, whether it's uppercase, the data itself, we can't touch that. So if I write and debug again, what do we get? Check it out. So in data, we do have our fields, and the keys are in. Oh, sorry, we're missing one key bit of data there, aren't we? When we do our decoding of properties, we should actually have. It's not just key we want to pass in. We want to make sure. So key here is actually equal to all of that. Adding the parent name on. We'll display it here for our curiosity purposes, and still we go again. Variables in keys. That's more like it, isn't it? Yeah. Now we're getting something that does something. At least now it saves, it puts the data into a structure. It's not a very good structure. Not advising anyone actually do it like this, but hey, we're giving it a go. We're having a bit of a go at it. Right, when we add a new section name, we have to add this to here. We're going to need to have, that's going to be full parent. The logic there is terrible, and it's add this parent to our key and data array. I think that should give us a representation of this file in memory in our array. Let's have a look. So in that keys section here, we've got pbproject.version. Yeah. I just want to try and pull one of those out. Alright, so look, we've got a lot of our document that's not very elegant, but we are actually getting some stuff out of it. if we have another function here that a public function this time, I don't know. Yeah, this might be getting a bit long. Yeah, no, I think we'll just leave it there. What you could do is you add a couple little functions to skim through here and find the parents and do that. But we'll have to do that next time. We've been going for about an hour already, so okie doke. I'll leave it there. Thanks for watching, and I'll see you next time. Bye.